Hi, my name is Mariana. I couldn't be in person, so I'm recording this video to share with you this work on teaching technical and societal aspects of IoT, a case study using the Orbit IoT Kit. So that was a work that was a collaboration between many people, mostly from the Center for Computational Thinking and Design and also the Department of Electrical and Computer Engineer, both in Aarhus University in Denmark. What is the Orbit IoT Kit? As you can see in this picture, is a microbit-based kit that allows students to control household items such as lamps or smart speakers and other objects through internet connection. This is a more detailed picture of what are the components of the kit. We have the microbits that go inside the extension board that was developed in the engineering department. And we have the relay that allows things such as lamps that normally wouldn't connect directly to the microbit. So the relay, that's what enables it. And here are the main functionalities of the kit. Besides having the microbit with all the sensors and motors and controlling the apps and devices such as Spotify, the smart speakers, we also have the custom block that allows the devices to send and receive data in make code so you can see in the different channels which messages are being sent to which devices. And we also have this dashboard that allows the visualization of the data. Our research question is, how does the Orbit IoT Kit support educators to teach students about the technical and societal elements of IoT? And for that study, we had 20 students as participants. They were 7th graders, ages 12 and 13. And we also had 3 teachers that were part of this participatory design process in which we were designing the activities with them. As learning goals, we have mainly 2. First, to have notions of how the data flow of the IoT system works and reflect on the societal implications of Internet of Things. We had these 2 research propositions. The first one related to internet communication. So the internet communication between the different devices can support teachers in explaining IoT concepts based on situated student experiences. And the proposition 2 is about visualizing data flows that can help teachers and students to discuss how Internet of Things works and its potential security issues. So that's one of the societal elements that we were talking about. As an overview of the activities, we had 2 days of activities. And in the first day, we had an introduction video to introduce the activities to the students. And that was a fictional hacker character that was inviting students to prank their teachers using Internet of Things. And we had some discussion about hacking, like what is a hacker and what are the types of hacker, how does relate to IoT. And then we had these hands-on tutorials that the students would control lamps and fans using the kit and the make coding environment. And for the second day, we had the students create their project about pranking the teachers. All the projects were really not harmful and it was in a really light, fun, playful way. And I'll give an example in a moment. But after that, we had a formative assessment activity that was to see how the students were seeing their own learning process. And finally, we had this ethical discussion supported by some videos created in Denmark about security and teenagers and how the students might relate to those topics. As an example of one of the projects, a group of students made a remote controlled fan that when a teacher would approach the book, the fan would turn on, so the pages would be flipping. About the results, the first one was how allowing students to personally and collectively experience the security issues in the classroom supported teachers to discuss the ethics of hacking with the students. That was something that we were not planning in the activity for the students to hack each other, but that ended up happening in a very organic and emergent way. And that was really fascinating to see how teachers, they were so open to it and very excited about it because then they could see the opportunity to link back to this ethical discussions. What happened was some of the students started to see in the dashboard the name of the channel, which means that they could control basically the other projects of the other groups. And that when that was happening, it was really fun. And then they were really excited and they were being mischievous and they were like, oh, this is so cool. But when other groups started to do it with them, then you get this quote of, it's so annoying to be hacked. So in this situation, they were feeling and really experiencing both the role of the hacker and the other end of it, of the consequences of that action. As a second part of the results, we had data visualization as a tool for supporting teachers and students troubleshooting and reflecting on security issues of IoT. As I mentioned in the first results, we like the data visualization was obviously used for that kind of hacking moment, but also throughout the activities, it was really important for also the teachers to see if the messages were being sent to where. So that was a really good way to just visualize and have this conversation and this facilitation between the teachers and the students about what was happening in that moment, especially if something was wrong and then they were troubleshooting it together. And as the third part of this result, we had the teachers' dilemmas regarding student struggles. Obviously, this approach or how we design these activities, they're not very traditional. So it was not that the teachers were just explaining about IoT and the students were receiving that information. There was a lot going on. And in the materials that we gave to the students in order for them to do the assignments, sometimes the teachers described as in the students, they didn't have the patience or they were just a bit lost in what they're supposed to do. So there was something about some confusion in understanding what was in the materials and what was the prompt that they were giving to do. There were very interesting conversations in our debrief sessions with the teachers that they were discussing, for example, in that short amount of time, in that type of activity, how much the coding part we should already give to the students, or they should just remake something that was already made. In this quote of what do I need this for is one of the students asking this question because in the teaching materials they were unsure what to use that information in that activity. From all this experience, we were trying to draw out some design recommendations for IoT kits that support teachers. So for other fellow researchers and designers and educators that are interested in teaching IoT, especially this also societal aspect of it, we were trying to provide some guidelines that would hopefully steer some conversation about the design of these kits. The first one is about connectivity. So provide realistic elements and internet connection to support discussions about security. Maybe if you are designing one of those kits, you might ask yourself, is my toolkit supporting teachers to create authentic experiential learning experiences? What type of societal implication my toolkit is exposing the students to? And in our case, we focus on security, but you might think about transparency. You might think about maybe other ethical situations or dilemmas that you want the students to explore. As a second design recommendation, we have visualization, glassbox the data flow to support explanations and troubleshooting. And by glassboxing, we mean the opposite process of black boxing, which is just making sure like that complex parts of the technology, they are not really seen or you're not going to explore that much. So the opposite of that would be this glass boxing, right? And in a very intentional way, just to expose a bit this visualizations, how this communication between the devices through the internet is actually happening. And if you are designing one of these kits or any other IoT kit, you might ask yourself, Do I know which aspects of the technology I want to glassbox? Like, does my toolkit have features that help students and teachers to visualize the aspects of the technology I want to glassbox? And does my toolkit give enough feedback information so students and teachers can troubleshoot when needed? And as the third design recommendation, we have openness. So allow unanticipated use of the tool to support flexible teaching. And if you are designing and thinking about how does that recommendation kind of gets in a more concrete way, you might ask yourself, does my toolkit support only a specific and predetermined tasks, or also it support unexpected tasks that teachers might create during the lesson? And that one was related to that emergent organic hacking part, right? Even though it's really important for the teachers to be open for this moments, but also if our kid was not robust enough to support that type of interaction, that moment wouldn't have happened. And if you're interested or curious or just want to know more about the activities that we created with this kit, those activities are available to the public and you can access them through our website, the Center for Computational Thinking and Design website. So if you go to cctd.au.dk and on the left part of the menu, you go on teaching materials. You can see here all like the Internet of Things materials. So we have a teacher's guide, a student's guide, and slides just to support these activities. Please feel free to reach out for any questions, comments, and feedback. Thank you.